Now that you've learned some essential basics for doing statistics, I'd like to walk you through some practice. So keep in mind that this uses not only what we went over in the lecture, but also what's in chapter 1 of your textbook. So make sure that you've read that before you go ahead and start the practice. So one thing that you can do with statistics, like I said in the lecture, is that you can assess how other researchers do their own research. So in this case, we're going to use some examples of people who put together studies or are starting to put together studies to answer a question. And your job will be to figure out what it is that they're doing exactly. So in this example, Dr. Appleseed is interested in testing whether the proverb of an apple a day keeps the doctor away is true. She is specifically interested in adults 18 and over in the United States. She recruits people from around her city to take part in her study. Now, this is actually a really interesting and useful way to start a study is to begin with something that the public thinks is true. And then we as behavioral scientists or psychologists will go in and test whether those things are actually true. So this could be done from a behavioral scientist point of view, a medical point of view, etc. But the methods will be very similar to each other. So for this example, I want you to think about what is the population? So what is the population that Dr. Appleseed is interested in? What is the sample she's using? And what is a variable in this study? Okay, so keep in mind the definition of a variable and what that could be for this particular example. And finally, for the number of apples eaten, is that going to be a discrete or continuous variable? And I want you to be able to defend why you think it's a discrete or continuous variable. So I'd like you to pause here and truly think about the answers for those questions. Keep in mind that in these practice sessions, it's best for you to try and grapple with the answers. That's going to be the way that you learn best. It won't be that helpful for you to go on and move to the answers as quickly as possible, but instead try and come up with something on your own. If you're wrong, that's okay. That's the process of learning, and it's better now than on homework or on an exam. So go ahead and pause here and try and answer those questions about Dr. Appleseed's study. So let's go back to Dr. Appleseed and answer some of those questions. So her population is all American adults. So you'll notice that she's interested in anyone who's 18 and over, and that's a good number of people. And so obviously she probably cannot even begin to recruit everybody in the United States who's over 18. And so she's simply going to go around her city and recruit some adults. And so that is going to be the sample. How she recruits them should be very carefully thought out, but obviously it will not be the same number of people as there are in the population that she's interested in. One of the most important variables, of course, is the number of apples eaten per day. So she may have people eat no apples versus one apple, or one apple versus one versus two apples, and then maybe measure how often people become sick or even go actually see the doctor. But for now, all we definitively know is that the number of apples eaten is likely going to vary within the study. And finally, the number of apples eaten here is continuous. I know some of you may have said discrete, and I think there's some, ability to defend it being discrete, but keep in mind that for the participants, they can eat 1.45 apples, correct? It is true that they can eat that many apples. It's not hard to do, and so that's going to be a continuous variable. And remember, the thing about continuous variables is that in theory, they are continuous, but often we don't measure them in a truly continuous way. So even though we are only going to count 1 versus 2 versus 3 apples, it is possible that people could eat somewhere between 1 and 2 apples and somewhere between 2 and 3 apples. So it truly is a continuous scale. And this is a ratio scale because, as you know, 0 is meaningful, right? So if someone has eaten 0 apples, that is the absence of any apples, and that is a score that Dr. Appleseed will likely be interested in. So that's your first example for these particular concepts. Okay, let's go ahead and move on to another example. In this one, we have a student, Michelle, who is a student in Psychology 375, which, as some of you may know, is a research-based course, and students must complete their own original research project. So Michelle has decided to research meditation and stress levels among Nevada State College students. She's going to measure meditation in time, so how long students meditate for, and then have students rate their level of stress on a scale that ranges from -3, so someone would pick a -3 if they're completely not stressed out at all the way to a +3 to where they feel very stressed. So you can imagine that the scale will go from -3, -2, -1, 0, 1, 2, and then 3. So therefore you have your two ends as well as some values in the middle. So the questions here are, what type of scale is meditation on? Okay, so we've already gone through one practice of these, so this should start to come to you a little bit more easily. What type of scale is stress on? And if Michelle finds a relationship between meditation and stress, would this be a statistic or a parameter? So these are the 3 questions that I want you to think about for this particular example, and make sure that you take a pause and then get to the answer. So for Michelle, meditation is on a continuous ratio scale. And remember, a ratio scale means that 0 is meaningful. So a 0 would mean that the student hasn't meditated at all, and we would be interested in the relationship between meditation and stress, even at that level. And again, you can't have negative time of meditation. In this case, though, stress is on a continuous interval scale. So remember, in this case, the 0 is sort of arbitrary, and it doesn't mean the lack of any stress, right? In fact, that's more of a -3, which is the lack of any negative stress. So the interval scale means that your 0 is arbitrary. It doesn't mean the absence of the variable that you're trying to measure. But it is still continuous. Even though we only have these 7 numbers for people to choose from, it could be that someone feels they're between a -1 and a 0, for example, but they're like, well, I kind of feel closer to the 0, so I'll pick that. Or I feel closer to a 2 than I do to a 1, so I'll pick the 2. So even though you as the researcher have decided to pick very specific numbers, the way people feel about their stress is still continuous. And if Michelle asks every single student at NSC how much they meditate and what their stress level is, then that would be a parameter. But it's more likely that she'll recruit a smaller group of students to ask about their meditation and stress levels, and then this would be a statistic because it's based on a sample. Let's go through one more example of a study. So this is a real study that was conducted by Judge and Cable and was published in 2010, in which they found that thin women have higher incomes than heavier women. So what happens is that you can clearly measure how much a woman weighs, and you can clearly measure how much she makes every week or month or year, and there is a relationship between these variables. So the thinner a woman is, the more money she makes. So the question is this an example of an experimental or a non-experimental study? So in the lecture, we went over experimental and correlational studies. So which one would it be in this case? So in this case, Judge and Cable have used a non-experimental study because the women were not assigned to be either thin or heavy. So there's a relationship between weight and income. We know that the less you weigh, the more you make, but the cause and effect relationship cannot be established, not through the data that we have here. So again, it could be X leads to Y, weight leads to income. It could also be Y leads to X. So the more you make, maybe the healthier you can eat, so the less you weigh. Or there could be some other variable that's happening that leads a woman to be both thin and making more money, right? Or heavier and making less money. So something that we did not measure in this study. So because it could be any of those explanations, we know that cause and effect cannot be established. So this is a non-experimental study and it's a correlational study. So for this question, I want you to think about measuring variables that can be a little slippery. So why is it that measuring something like love between people in a romantic relationship is considered a construct? So for this question, I want you to think about what love is, how we might measure it, and the definition of a construct and why we would consider it to be a construct. So go ahead and pause for a second, write something down, give me something to work with, and then check out the answer. So in this case, a construct is something that can't be measured directly. And love is definitely one of those emotions that is hard to pin down. Even if you ask a few people what love is, you're going to get different answers from different people. And so instead of trying to measure that directly, which is practically impossible, we go to behaviors that could serve as stand-ins for love. So we might pick a behavior that if love is very high, we would see more of that behavior. And if love is rather low, we would see less of that behavior. And so I want you to think about what kinds of behaviors would you think would be good for measuring something like love. And that's what a behavioral scientist has to think about. What is a really good, valid measure that I can observe or write down or have someone fill out that's going to be able to stand in for what I'm truly interested in. Okay, so the final practice question is for you to practice on your own. I won't give you the answer. And so this question is very long. I can see that. And so I'm going to read through it with you. And then I want you to think about your answers to this question or these questions. So this is again based on a real study. So this is Weinstein, McDermott, and Roediger. And they conducted an experiment to evaluate the effectiveness of different study strategies. So they wanted to see if students study in different ways, which one will lead to the best outcome. So one part of the study asked students to prepare for a test by reading a passage. So this is a test that doesn't have anything to do with their actual grade. This is in the lab, aside from any classes they're taking. In one condition, the students generated and then answered questions after reading the passage. So generated questions about the passage that maybe they would ask another student who read it. In a second condition, students simply read the passage a second time. So they didn't ask any questions, they didn't answer any questions, they simply read it again. All students were then given a test on the passage material, and the researchers recorded the number of correct answers. So for this example, I want you to think of what type of scale is used for the type of study strategy. And this is a little difficult, so I really want you to think hard about it. What type of scale is used for the type of study strategy? The second question is, what is the type of scale used for the number of correct answers? Okay, so what kind of scale is used for the number of correct answers? And let's assume that this is a multiple choice test. And finally, is the finding that the researchers come up with a statistic or a parameter. Okay, and I want you to be able to defend your answer for those. So this is the end of the practice for your introduction to statistics. I hope it's been somewhat fun. I know that it's not everyone's cup of tea, but again, you get to learn about people and their behavior and their attitudes and thoughts. So good luck and have fun with it.